If you hear the word eclipse, it is easy to think of crowds, glasses, and dramatic photos. But NASA science through shadows makes a simpler point. These events matter because alignment changes light in ways scientists can measure. That matters now because recent North American eclipses, the Lucy occultation campaign, and new solar missions all show the same idea at work. A shadow is not just a visual effect. It is data. When one object moves in front of another, even for a moment, the blocked light can tell us about size, shape, distance, motion, and sometimes atmosphere. So, this is not only a story about watching the sky. It is a story about how a brief shadow can answer practical questions in astronomy. And once you see that, eclipses stop looking like rare spectacles and start looking like experiments that happen in public. The core method is straightforward. Scientists watch how light changes when one object passes in front of another. In a solar eclipse, the moon blocks the sun. In occultation, an asteroid briefly blocks a distant star. In a transit, a smaller object crosses a larger bright disk. Each case produces a timed change in brightness. That timing helps refine orbits. The amount of dimming helps estimate size and shape. In some cases, the way light fades can hint at an atmosphere or other material around the object. NASA's article groups these events together because they all rely on the same principle: careful observation of changing light. That is the real payoff. You do not need to touch a distant object to learn from it. You can read the shadow it casts. In astronomy, where direct access is limited, that makes alignment one of the most useful tools available. Science through shadows also stresses that not all eclipses do the same job. An annular eclipse happens when the moon passes in front of the sun but appears slightly smaller, leaving a bright ring around the edge. A total solar eclipse happens when the moon fully covers the sun's bright face and reveals the corona, the sun's faint outer atmosphere. That difference matters. The article notes that the October 14, 2023 annular eclipse helped explain eclipse geometry and safe viewing, while the April 8, 2024 total eclipse gave scientists and the public a very different view of the sun. It also addresses a basic question many people ask: why do eclipses not happen every month? The answer is orbital alignment. The sun, Earth, and moon have to line up in just the right way. So even before the science starts, the event itself is a lesson in how celestial mechanics works. One of the clearest examples in the NASA material is Polymele. Before NASA's Lucy spacecraft flyby, astronomers wanted better information about this Trojan asteroid. On February 3, 2023, more than 100 telescopes across the continents were positioned to catch the moment Polymele passed in front of a star. That is an occultation. For a very short time, the asteroid blocked the starlight and cast a moving shadow across Earth. Observers at different points recorded whether and when the star disappeared. Put those timings together, and scientists can estimate the asteroid's size, shape, and position more accurately. This is a good reminder that shadow science is not limited to the sun and moon. It can also help prepare for spacecraft missions by narrowing uncertainty before a close encounter. A fleeting shadow on Earth can sharpen our picture of a small body millions of miles away. The last important point is about participation. NASA presents science through shadows as more than a film series. It is part of a broader effort to make astronomy legible and usable in classrooms, libraries, planetariums, and citizen science projects. The article points to eclipse campaigns like the nationwide Eclipse Ballooning Project and Citizen CATE 2024, where students, educators, and volunteers collected atmospheric and solar data during recent eclipses. That matters for a China Big Questions audience too, because it shows how science capacity is built not only through flagship missions like Parker Solar Probe or PUNCH, but through public networks that gather evidence during short-lived events. The deeper lesson is modest but important. Astronomy is not only done in remote observatories by a small circle of experts. Sometimes it is done by many people spread across a shadow path, each adding one small piece to a larger measurement.